In the first video for the trig part 1 section, I just kind of gave a little outline of the difference between radian measure and degree measure. All right. Degree measure in general was like the amount of rotation, whereas radian measure was the distance traveled around a unit circle, right? A circle that has a radius of 1. Okay. Now we're going to move into right triangle. First, geometry. Right? Before we get into trigonometry of the right triangle, we got to talk a little bit about geometry of a right triangle. Okay. So in general, that would be your basic right triangle. All right. And what they would usually do is they usually put a little box here to represent the right angle. Okay. And usually in geometry classes, these triangles are going to be labeled triangle ABC. All right. So those are called the vertices of the triangle. And in general, the right angle, right, the vertex where the right angle was in general called C. So you can label these two ones A or B generally in any way you want. So this would be A, this would be B, and this would be C. Okay? And probably the first thing you do with triangles, right, in geometry class is you say, well, these three angles here, right, they have to add up to 180 degrees, right? So the sum of the three interior angles of the triangle was 100 degrees, was 180 degrees. So that would generally be written as angle A plus angle B plus angle C equals 180 degrees. Okay? And of course, since angle C is a right angle, right, just with simple algebra, if you replace this with 90 degrees, right, angle C, and then you subtract it from both sides, you get the fact that angle A plus angle B would equal 90 degrees. So that's an important fact right there. The fact that angle A plus angle B equals 90 degrees. Okay? Angle A and angle B are the smaller angles of the right triangle, right? These are known as acute angles. They're less than 90 degrees. And of course, the right angle is 90 degrees. Okay? So angle A plus angle B add up to 90 degrees. And those kind of angles have a special name. They're called complementary angles. Not complement, like you would pay someone a compliment, complement. So they're known as complementary angles, angle A and angle B, because they add up to 90 degrees. So for example, if angle A was 20 degrees, angle B would be 70 degrees. If angle A was 40 degrees, angle B would be 50 degrees. Okay? So you know the three angles of the triangle add up to 180 degrees, and since in a right triangle, one of the angles is 90 degrees, you know the other two angles, right, the acute angles, angle A and B, would be called complementary angles because they add up to 90 degrees. So we're still working with our right triangle ABC, right, where C is the right angle and angles A and B are the two acute angles, right, that are complementary angles. They add up to 90 degrees. Now, in the last video, we just related the angle measures, okay? We said that they add up to 180 degrees. Now we're going to relate the sides, okay? And what usually happens with the right triangles is, if you have right triangle ABC, what you do is you call the side that's opposite angle A lowercase a. You call the side that's opposite angle B lowercase b. And you call the side that's opposite angle C lowercase c. Okay? And you probably recall this from geometry. Lowercase a and lowercase b are known as legs, and c is known as the hypotenuse, right? So this would be the hypotenuse, and then a and b would be legs. All right, so you have legs and you have the hypotenuse. And again, sides are going to be named with lowercase letters, whereas angles are going to be named with uppercase letters. All right, so it works out nicely. the fact that lowercase a is opposite capital A, lowercase b is opposite capital B, lowercase c is opposite capital C. And of course, you probably recall the famous relationship between the sides of the right triangle, which is known as the Pythagorean theorem, which tells you that if you take the sum of the squares of the legs, right? So the squares of the legs would be a squared and b squared. If you take the sum of those, so in other words, if you take a squared and add it to b squared, that result is the same as the hypotenuse squared, right? The length of the hypotenuse squared. So you have a squared plus b squared equals c squared, and of course this is known as the Pythagorean theorem. So the Pythagorean theorem gives you the relationship between the lengths of the sides of the right triangle, right? So now we have relationships between the angles in the right triangle. We have relationship between the lengths of the sides of the right triangle. So when we get into trig part 2, we're going to get into the relationship between the angles and the sides, right? We're going to interrelate them. All right? So that'll be in trig part 2. Now that we have the relationships between the sides, the relationships between the angles, we can just give you a couple quick examples of the kind of problems they could ask you dealing with this. All right. So first with the angles. All right. So they might say something like, in a right triangle, which we have here, angle A is 5 degrees less than angle B. What are their measures? Right? So what are you doing here? You're just looking for the measures of angle A and angle B, right? The two acute angles in the right triangle. And you know that angle A is 5 degrees less than angle B. So this gives you the relationship here, okay? And generally, you want to probably just do this with a single variable. I mean, you could use an x and a y here, but it's probably easier just to use a single variable. And in general, when they give you the relationship between two unknowns like they do here, but you know, the relationship between A and B, normally the thing that they mention second is the thing that you want to just call the variable, right? Like x or y or whatever you're going to call it, okay? So in this case, the thing they mentioned second would be angle B. So you'd want to call angle B x, right? So you'd go and you'd say, all right, so let x equal angle B, right? So if x is angle B, what is angle A? It's 5 degrees less than that. So if angle B is x, and angle A is 5 degrees less than x, what is that, right? 5 degrees less than x would mean x minus 5. So x minus 5 is going to be the measure of angle A, okay? So you have x is the measure of angle B, x minus 5 is the measure of angle A, and again, from before, what do we know about the relationship between angle A and angle B? They have to add up to 90 degrees. So we know that if we take angle A, which is, I'm sorry, angle B, which is x, and add it to angle A, which is x minus 5, we have to end up with 90 degrees, right? So, I mean, this is how they work algebra into a geometry problem, right? You have a little equation here now to solve. So this is a very simple equation to solve. Just add up the x's, because, again, these parentheses mean nothing because it's just addition. So this is just 2x minus 5 equals 90. Add 5. 2x is 95, so then x is going to be 95 over 2, which is really 47.5. Right? So x is 47.5 degrees, which is angle B, and then x minus 5 is going to be 47.5 minus 5, so it's going to be 42.5 degrees. So we know that angle B is 47.5 degrees, angle A is 42.5 degrees. Okay, so that's just a simple example. And again, I mean, they can use radian measure also instead of degree measure, right? Like in this, they could have said angle A is, pi over 36 radians less than angle B, because pi over 36 radians would be 5 degrees. Okay, so they could have said that also. All right, and then you would just use radians instead of degrees. So we gave you an example with the angles. Now we'll give you an example with the sides of the right triangle. Okay, so again, a very simple example. Suppose B equals 15 and C equals 17, and I want you to find A. All right. Now, I mean, they don't have to phrase it this way. I mean, they could just tell you something like, suppose one of the legs of the right triangle was 15 and the hypotenuse was 17. Find the length of the other leg, right? That's another way of wording this problem. It doesn't matter which leg I call B, which leg I call A. I mean, I could have said that A is 15 and C is 17, find B, and it would be the same process, right? A and B are pretty much interchangeable because they're legs, right? Now, C has to be the hypotenuse, right? So C is always the longest side, okay? That has to be the hypotenuse. So again, I mean, I just use the relationship I know between the sides of the right triangle, which is the Pythagorean theorem. So I would just say, all right, well, I know that A squared plus B squared equals C squared. And now it's just a matter of substituting the values, right? So I know B is 15, C is 17. So I would write A squared plus 15 squared equals 17 squared, okay? And 15 squared is 225, 17 squared is going to be 289. So take this over here, and I would have that A squared plus 225 equals 289, right? So I would just subtract 225. So I would have A squared equals 289 minus 225. It's going to be 64. And I mean, at this point, we haven't worked with quadratic equations, which is what this is, but if you remember, in general, how did you solve equations always? You always kind of did the inverse operation, right? The operation that would undo whatever's being done. So in this case, squaring is being done. So the inverse of squaring would be take the square root of both sides, okay? So the square root of A squared is just going to be A, and then the square root of 64 technically would be positive or negative 8, but it's a length, so it's just going to be positive 8. So we know that the other leg would then be 8. All right? So we have 8, 15, and 17 as the three sides of our right triangle. Right? And this is actually one of the famous, what they were called Pythagorean triples, 8, 15, 17. They can, if you remember what they are, they can save you a little bit of work. The Pythagorean triples generally that show up in problems are usually ones like 3, 4, 5, 5, 12, 13. This one here, which is 8, 15, 17, and then 7, 24, 25. All right? So I say that those can save you a little bit of work because, like, let's say the problem was similar to this and it said, all right, well, one of the legs was 7 and the hypotenuse was 25. What's the other leg? If you remember this triple without even doing any work, you would say, all right, the other leg has got to be 24 because of the 7, 24, 25. Right? The 3, 4, 5 is really the one that comes up most frequently. And, I mean, you can see that it works very simply just by doing a check. 3 squared is 9. 4 squared is 16. So when you add up 9 and 16, you get 25, which is the square root of 5. All right? So that triple is easy to see. And then the other thing that's nice with these is multiples of these also work. So like 5, 12, 13 works, but also this triple times 2 would work. So like 10, 24, 26 would be another set of legs and hypotenuse that would also work. Right? You could just multiply all these by any number you wanted, and then you would get another set of legs and hypotenuse that would work. All right? So they're good to keep in mind, just in case they come up on a quiz or test problem, because they can save some time.